Okay, so where are you? So you hear me? Yeah, so what I'm planning to do with this talk is to give a context, give a sort of a where we are. And since this is the second in this illustrious series of analysis ecosystem workshops, I was going to frame it in terms of that, where we are since 5 years ago. And then the ending part of this, I'll be saying a bit about the Analysis Grand Challenge workshop, which is closer. Okay, then I'll do that now. Okay, so the thing, I mean, there are a few charges that came from the first Analysis Ecosystem workshop, but the one that that I kept hearing bounced back and forth, with the people I'm working with, and certainly in my own head, was this business about Python being treated as a first-class language. Saw this sort of as a charge. And this has touched a lot of things, as a lot of you know, and we saw that in root with the PyRoot becoming more Pythonic, but we also saw it beyond root. That's what I'll be talking about here. And I'll be showing sort of this history in say 5 plots. So some of these I've shown before. And all of these, they're going to have time on the horizontal axis, and the vertical axis is going to be different kinds of metrics to try to quantify adoption or developer activity or such and such. But each of the vertical axes is different, so I'll have to explain each one of them. In this one is talking about Python's adoption in the world beyond HEP, in the larger world. The vertical axis is Google search volume, and these are finding the words Java associated with analytics, or R or Python. And at the time of the first Analysis Ecosystem workshop, R was more popular for data science, for data analytics, than Python was. But we could see that it was going in that direction. And also, most of what happened with machine learning was yet to come. But still, when we're seeing, starting from here, it was pretty clear where this was going. Now, within HEP, taking a very long view, here the vertical axis is what people are talking about at CHEP conferences. So titles and abstracts and matching. Okay, we'll have some questions at the end. Matching different, how many people are talking about Fortran? How many people are talking about C++? And we see the language transition that happened there. An interesting thing that along with this burst of C++, when we switched from Fortran to C++, at that same time, also Python just entered in very, very slowly, sort of under the radar, slowly growing that whole time. This is not a thing that I knew before doing this kind of analysis. From the very early year 2000, there are slides where Lucas Taylor is noticing that a lot of people are talking about Python, and really nothing's happened yet. And this is where the analysis ecosystem was. What's really changed in the Python world is what we're doing in the Python scripts. So for most of that history, Python was driving the configuration of it was not being used as Python. It's not being used for analysis. What was really changing in that time is what people are doing with it. So here, the vertical axis. I've narrowed in on GitHub users who have also forked CMSSW. So these are CMS users. And I just look at all of their repos, full text search of all their code that they've written, searching for things like import XYZ, or in the case of C++, include this, include that, a long list of root include files. And we see PyRoot is on the rise. I want to make sure that that's not missed here. But what is very much on the rise was the use of NumPy, Matplotlib, Pandas, TensorFlow. That, at the time of the first analysis ecosystem, this was just sort of a thing that some people had heard about and some people have toyed with, but it really hadn't taken over the way that it has since. And it's worth pointing out it has since. Now narrowing in even further, Scikit HEP project, representing sort of an umbrella organization of a lot of Python packages that are being developed, sort of they start off being developed independently and then they're gathered together. The download rate, that's the vertical axis here, has increased 50 times from the first analysis ecosystem to now. And also, if you break that down by which package, there's a lot more packages too. You know, this is the sum of all the packages. So before the line, there was only like 8 of them that are really noticeable there. And then the last plot, which is just a collection of survey results. This is from the PyHEP 2020 survey when we had some 40% answering the survey. And they were showing us, you know, a lot of the same things that we're getting from the data-driven plots, that really we're getting into this world now that is a somewhat even mixture of Python and C++. We're not going to a Python-only world, and we can see that in the data. So the Pythonic HEP ecosystem now is a lot more filled out. We can make these kinds of layer diagrams where we have the base layer is like the stuff that we get from outside of HEP, and then layers on top of that of increasing specificity. And you know, all of these are like separate independent projects that talk to each other. And to show kind of how this can work, how you can have this, you know, everybody's like making their own project and then, you know, how to fit them together. I'm going to go through a case study of how histograms have developed in Scikit HEP. So it's just a case study, just talking about histograms. The scientific Python world lacks HEP-style histograms, or at least before. By scientific Python, I mean like NumPy, you know, cloud and industry. They just don't do histograms the way that we do. So it's one of the things we have to make ourselves. And also, it seems kind of easy. Like to make a histogram package in Python, you start by just bin and count, right? And a lot of people have started that way. In fact, I've been able to find 20 histogram libraries in Python, and most of them are single author, and most of them lived and died. Most of them are not present. So putting this into a plot, because you can git clone each one of these and explore them all. Make another time plot. When did they live and die? And this is the developer activity on them. So now here, the vertical axis is the number of unique monthly commits. So if it's higher here, there are more developers working on a particular package. And here, just to be clear, that what I'm talking about when I'm calling root here is not all of root. It's just the part of root that deals with any of the histogram classes. So I listed them out. I'm tracking about 400 files there, but it's just the histogram part. And so you see some of these things. RootPy was a thing once. It was too early. When the scientific Python stuff was starting up, this is when you have this proliferation. This is when everybody said, oh, I'm going to make the histogram. I'm going to do the histogram library. And for most people that, you know, that didn't last very long. Including actually coffee is one of these. It's much later. And what is going up very high is a conglomeration of boost histogram, hist, and MPL HEP. I take those set and call them all one thing, and there's a very large number of people contributing to that group. Now, why is it, you know, legal? Why is it valid to group them as one thing? Is because they are kind of a combined thing now. They started off as single individual packages. They started off, Boost histogram was a part of Boost, and it was working, you know, Hans Dembinski was working on it for many years and got it into Boost. It's a C++ thing, independently of any of this before any of this other work. There was also a lot of work on interfaces with Matplotlib and ways of presenting these graphics, which were all just, you know, separate pieces. What happened here is that these were pulled together with other packages, so that now you have so the Boost histogram with a hyphen is a thin wrapper around Boost histogram C++, And then hist is a fully fixtured thing that brings in all of the plotting, so that from a user's point of view, it's import hist. They see just the final dependency of all of this. But all of these pieces grew at first independently and then coming together. That's how this is supposed to work. That's how this this sort of modularity of, we don't want just 1,000 flowers to bloom and that's it. We don't want packages to live and die. We want them to come together. And now if you take this group, there's 47 developers have touched this group, and some 20 of them have been touched multiple. So it's people all sort of intermesh work on all this. And how they glued together, they're glued together with protocols. And having been involved in some of these arguments, we have to hammer it out to figure out how these things are going to talk to each other and then abide by the decisions. So this is how, this is sort of a case study of just histograms, but this is how it all came. Now, another thing that's like it, another one of these sort of end user thing that just sort of imports the world, Uproot Browser is a way of acting with these packages, these diverse packages that are all doing some part of the analysis in a single umbrella view. And this was done as a text user interface, which I'll just sort of go through this. You can scroll around, you can click on things, and you can use it. It is like a T browser. Exit it. Now, why text? I'm not really sure. That seems a little odd to me. This is certainly not the way I would have thought of doing it. But the point is, Uproot Browser is not Uproot. This is one way of viewing this. If you like that, you'll buy into that. If you like a different way, buy into a different way. So now getting back to the ecosystem as a whole, what we can show now that we didn't have some 5 years ago is this feature completeness. It's now the case that full analyses can be done with just the scikit-HEP tools. And here's an example, one from Nate Greiser, and this is my lead-in into the analysis Grand Analysis Challenge workshop. This is an LHCb analysis that was done entirely with scikit-HEP tools. And a thing that I would really want to emphasize with this is that I don't think it's that the point of what we're trying to do here is to replace root. In fact, you'll find in the original slides from 5 years ago that is entirely not what we're trying to do. This is, use any tool that gets the job done. The reason that I'm showing this is because it shows that you can. It shows that enough of the ecosystem is filled out that it's possible. And that's what I wanted to show with this, is that there aren't the gaps that there used to be. So now getting more into the Grand Analysis Challenge workshop. This was, I should have reminded myself how long ago it was, but how many days, how long ago? A couple weeks ago. A month ago, see what happens. And it was showing all of the pieces that are going into, so the Grand Analysis Challenge is a project to show all the steps of an analysis facility, getting the data out, doing the full, doing a full scale analysis. And so at the workshop, showing, not just the pieces, but also tutorials of how you do it. Okay, so these are some overview. This page is mostly for links. You'll be able to find out more information about this. And the last few slides I have are just showing some examples, some things that were pulled from this workshop that I think is just really impressively showing how this is coming about. How we used to always show like as a tutorial and such. This is a tutorial. This was teaching people how to use the tools, and it's doing what looks to me like a pretty complete TT bar analysis. And what I find just great was all of the physics was in one Jupyter Notebook cell. This is the cell. And well, whoops. Sorry. And yeah, it's okay. Yeah, of course, it's a big cell. It makes all of those plots. But you know, if your analysis script is that short, that's also. And this wasn't the only tutorial. There were also tutorials with limits. And this one is showing a lot of the things you do with cabinetry, IHF, and reproducing a published result. The differences are understood as per where the samples are. But the fact is that you can reproduce the shape where there were samples. And so, okay, so this in the large scale, this is connecting many different areas of activity, from DOMA to analysis system tools to scale systems laboratory, or actually running these analyses. And it's pulling together a lot of the different pieces of tools, not just the big bag of logos of the analysis tools, but also, you know, the logos for Surface X delivery, FunkX, Xcache, Skyhook, Coffee Casa. Yeah, so finally, I would just like to end with some of the slides from 5 years ago, because the point I'd like to make now is that what we were talking about 5 years ago is happening now. We're going to see that. So first, Scikit HEP. This is Eduardo's slide. Vision for what Scikit HEP is supposed to be, what is that has come to be. It's not a replacement for root. It's not a replacement for the Python ecosystem or the NumPy and such. It's building on that. This is exactly what we have now. This is from Gerhard Raven, talking about how to benefit from the code that's out there. And that is happening. I liked this one because Gordon was showing what analysis description language would look like, and now it's running in Jupyter. And then I was talking about something which completely stopped the day after I got back. I was talking about femtocode. Right? This is my big project for over a year at that point. After that workshop, I completely stopped. I looked at my Git logs. Not a single commit after the date of the workshop. The day I got back was starting on a project that went through actually like 8 different names, the last of which was awkward. And also, I want to say, you know, we talked about query systems there, and now we went through a few different names. Now query systems are called analysis facilities, but you know, we went from pretty naive ideas about how that would work to a reality with all the pieces in it. You know, at this tools workshop, you know, stuff about the the details of the security. That wasn't even a thought. So it's really happening. That's all I have.
So let's see, we have time for 1 2 questions. Please raise your hands. Yeah.
So I think on slide 25, you show all this battle arena of Python package. No, it was not this one. Much more in the beginning. Oh yeah, sorry. I mean. Oh yes, the logos. Yes. So is there any particular reason why PyRoot is not included? Because it's also a Python library.
In the talk as a whole, I didn't want to step on toes. I knew that we were talking about PyRoot right before it, and so actually at the beginning of this talk, I wanted to emphasize, you know, this charge about Python really was about PyRoot as much as This this is Pythonic HEP. Actually, I think I was going to say also coffee isn't under it, but no, actually it is there. Yeah, it's not a root, and pyroot is a very important part of this whole. Important part of this. Yeah, I was going to give the fact that coffee is not officially a scikit-HEP project, so that's why I was going to say. And so you don't see that here, and then. So yeah, this I mean, yeah, it is. Because this is referring, that's the logo for the wrapper.
Hi, Jim. I have a question for the time series that you showed, where you have the ascendancy of Python. I think a few, yeah. No, where it's like analytics and machine learning. So Python machine learning seems to have passed the peak. What's happening there? Are we stopping with machine learning?
What I think is happening there is COVID. A lot of metrics dip in 2020, 2021. And if I extend this further, sometimes they back up.
I'm sorry, but we have to move on. So thanks again, Jim, for such an interesting discussion.